Let's proceed to tutorial question number 4. Given the structure of compound A below, and then name compound A according to IUPAC name. So we can see the functional group over here is hydroxyl group. So and then definitely number from the left hand side will give the lowest number to the carbon that attach with the hydroxyl group. So carbon 1, carbon 2, carbon 3. So here we have the two possibilities. Either is continue to the right or go down. For sure, we know that we need to proceed to the right so that we can have the longest carbon chain. Carbon 5, again, go down or go straight. We also will have similar number of carbon. So we just proceed from to the right hand side. So and then 6 carbon means that is hexanol. And then the hydroxyl group at the second carbon. The substitute is at the third carbon and the fifth carbon. Both substitutes are the same. So this one will become 3,5-dimethyl 2-hexanol. So we settle for question A. Question B, classify the alcohol A. So when classify, that means they ask us to say that it is primary, secondary, or tertiary alcohol. So from this question here now, this is the alpha carbon. And then this alpha carbon, left hand side with 1 carbon, right hand side also with 1 carbon. The third bond is hydrogen, the fourth bond is OH. So they are only bonded the 2 hydrogen. So the class of the alcohol is secondary alcohol. So is A is optically active. So if optically active, basically means that it will consist of chiral carbon. So we have so many carbon here. Which one is the chiral carbon? They must have 4 different groups. Okay, so before we proceed, so we erase all what we have marked down here. So with very quickly, we just check carbon 1, definitely no, because 3 hydrogen. So carbon 2, just now we already know, 1 is hydrogen, another one is OH, CH3, and then the other group is this big group. Okay, so means that I will have idea. The second carbon is the chiral carbon. So the second carbon is the chiral carbon. Okay. This is the chiral carbon. So and then the third carbon over here also will have another group. One is CH3. Okay, and then another one is hydrogen. Another group is this one, and the fourth group is this one. So the third carbon also considered as chiral carbon. Okay. So this CH2 no need because we have two hydrogen. Okay. So this is not chiral carbon. This one also not chiral carbon because have 1 hydrogen and then CH3, CH3. These two groups are same. So this carbon is not chiral carbon, have 3 hydrogen. This carbon also not chiral carbon because have 3 hydrogen. So in this context, is A optically active? Yes. Okay, explain your answer because consists of chiral carbon. Okay, question D. Write the complete equation when A reacts with hot potassium dichromate in aqueous sulfuric acid. So sulfuric acid, we have the acid, hot, potassium dichromate. Potassium dichromate also play the role as KMnO4. So from here, basically, this is what we always mention, hot acidified KMnO4. So when we see the potassium dichromate, so we know the reaction here is oxidation. Okay, and then sodium metal and then sodium chloride in pyridine. Okay, so we will going to show you the equation in next slide. Okay, proceed to D1. So this is the secondary alcohol, and then react with K2Cr2O7, which is the oxidation. So just recall back, based on the notes that you go through, we will know that primary and secondary alcohol can undergo oxidation. However, tertiary alcohol cannot be oxidized. Okay, so see this, we will know it is oxidation. So, and then maybe you have to remark as well, for the primary alcohol, okay, if react with weak oxidizing agent, it will produce aldehyde. Okay, if primary alcohol react with strong oxidizing agent, it will produce carboxylic acid. However, for the secondary alcohol, undergo oxidation will produce ketone in general. So it is very easy, just the OH will replace with the double bond O. Okay, so from here we know that in this condition, the oxidation is not gain oxygen, but in this case is lose hydrogen. So next question number 2, which will react with the Na. As we know, Na is a reactive metal, and metal always will form positive. So means that they will break the bond between the O and H, because oxygen is partially negative, and then the hydrogen is partially positive. So end up we will have O negative, Na plus. The hydrogen will replace by the Na plus. Other structure will maintain the same. So the third one, sodium chloride, which is SOCl2 pyridine. So SOCl2, the Cl will going to replace the OH, because Cl is partially negative. So we will replace the OH with the Cl, because in this case, the bond between carbon and oxygen, carbon is partially positive, while oxygen is partially negative. So the OH will be replaced by the Cl. So from this question, we have idea that for alcohol, they might have two types of the breaking. Either is break between RO with the hydrogen, one type of reaction, or alkyl group with the hydroxyl group. We have two types of reaction. Tutorial question number 5. Based on the following reaction scheme, identify the reagent G, H, I, and J. So when you want to answer this question, maybe we can do the spot the difference. So for this alcohol, we have the hydroxyl group, and then the different part is here, the Cl. So therefore, when you refer to the mind mapping that you have in your lecture and in your notes, so maybe you will notice that the G can be PCl3 or PCl5 or SOCl2 in pyridine. Okay, so all these reagents consist of Cl, can replace the OH. Okay, then another second part here is the hydroxyl group become carbon-carbon double bond. So we know this one is dehydration. So dehydration of alcohol, we need the concentrated H2SO4, and then the condition is heat. Okay, next one here we will focus on we see the J is the hydrogen replaced with the K plus. So here will be the potassium metal. And for the I, from the secondary alcohol, you will notice that now it's become ketone C double bond O. So this is an oxidation process. So if this is the oxidation process, so we can use hot acidified KMnO4. Okay, so that's all for this question. Tutorial question number 6. So based on the reaction scheme as well, and then you need to give the structural formula for the Kl, M, and N. So as usual, we have to identify the functional group. So in this compound, we have two functional groups. One is carbon-carbon double bond, and another one is the hydroxyl group. So when meet with the SOCl2 in the pyridine, so we know that the hydroxyl group that will be react with the SOCl2. Hence, the structure for the compound K is CH3CH. Since the double bond won't react with the SO2, so the double bond will be remain. And then CH3, CH2, CH, CH3. So the OH will replace by the Cl. So now the compound has the double bond and also have the halogen. So when we see the KCN, so we know the KCN will react with the haloalkane. KCN will react with the haloalkane, which will replace the Cl with the Cn, which undergo nucleophilic substitution. Okay, so when we have this structure, so CH3, CH, the double bond will maintain, and then CH3, and then carry out CH2, CH, CH3. So the Cl will replace with the Cn. Okay, then next one will be the react with the ozone followed by the hydrolysis. So when we look at this, we know this is the ozonolysis and only will happen at the carbon-carbon double bond. So what will happen to the structure now? So now this structure will going to break down to two parts. As we already know, this first part will become CH3, C double bond, and then we add one oxygen and then hydrogen. So for the other one, double bond, and then we have CH3, we have CH2, CH, Cn, and over here is CH3. So we just add the oxygen next to the carbon-carbon double bond. Okay, and then please don't forget to label. So the green color here is compound K, and then the red color is compound L, and then we have C2H4O. So this is the compound M, and this is the compound N. So we already finished answer question number 6. Question 7. Show the preparation of propanol from propene. So from this statement, we know that propene is the reactant, while the product is the propanol. So propene consists of 3 carbon, and then with 1 double bond. So complete with the hydrogen, CH2, CH, CH3. And then from here, because we are in the chapter of alcohol, so basically maybe you need to relate with the alcohol. So propene, if want to produce alcohol, means that we can react with water, acidified water. So at where undergo electrophilic addition. So if undergo electrophilic addition, we have to follow the Markovnikov rules at where break the double bond, okay, then form 2 new single bond. Break the double bond, form 2 new single bonds. Let's say these are the 2 new single bonds. So the electrophile, in this case, which is the hydrogen part, will attach to the carbon with more hydrogen, and then this one will become the attach another second new bond is bonded to OH, which to produce secondary alcohol. So secondary alcohol, if want to produce propanol, means that is undergo oxidation, at where we can use KMnO4, H plus, and heat. So the functional group of the hydroxyl group CH3, CH3, the single bond H and OH will become double bond O. Okay, because we are going to lose hydrogen. Okay, in this case they didn't gain oxygen, but they more to lose hydrogen. Okay, also is the process of oxidation. Okay, next one we are going to proceed to B, which is ethanol, and then to 1,2-dibromo ethane. So from ethanol, 2 carbon, CH3, CH2OH. So basically will undergo dehydration to produce ethene, which is CH2, CH2. So alcohol to become ethene, we need concentrated sulfuric acid and then heat. So then next, the alkene will react with bromine, Br2. In this case, because both Br dibromo, so we have to use the solvent CH2, Cl2 to produce CH2, single bond CH2, break the double bond, form 2 new single bond. Both new single bond is bonded to the Br and Br. Okay, tutorial question number 8. Give a chemical test to differentiate the following pair. Since we are in the chapter of alcohol, the Lucas test, the chemical test that we discuss in this chapter alcohol is the Lucas test. So for the primary alcohol, basically is no cloudy solution after 5 to 10 minutes. Okay, while for the secondary alcohol, there is cloudy solution after 5 to 10 minutes. Tertiary alcohol is cloudy solution immediately. Okay, cloudy solution after 5 minutes is same, and then cloudy solution form immediately. Okay, then now we have to specify the necessary reagent. So the reagent is ZnCl2 in HCl. Appropriate observation, roughly we already discussed just now. And next is the chemical equation involved. So for the structure A, toluene, this is toluene, a benzene ring attached with a methyl group. Cyclohexanol, so have a cyclohexane first, and then one of the carbon attached to the OH. So one is consists of benzene ring and another one is alcohol. So let's say the alcohol will react with the Lucas test. So this is secondary alcohol. So we can see the changes. So secondary alcohol, if react with zinc chloride in HCl, the OH will be replaced by the Cl and then will produce H2O. So we have the reagent over here. This is the reagent, and then we have the equation, and then next we need the observation. Okay, so the observation in this case is cloudy solution is formed after 5 to 10 minutes. Okay, then 2-methyl-2-butanol, 2-methyl-2-butanol, 4 carbon, and then second carbon have OH and then have CH3. So this is CH3, CH2, CH3. So for the question B, this is a tertiary alcohol. And then we have another butanol with 1 butanol. So complete with CH2. 2-methyl means that here we have CH3. Sorry, this is the single bond. And then we still need another hydrogen, CH2 and CH3. This is primary alcohol. So in between these two tertiary alcohol, we'll have the changes, and then the cloudy solution is formed immediately. Okay, so in the next slide, I will show you the complete answer. Okay, this is what we generally discuss. Okay, before you write the proper answer, you have to draw two structures and then see in between these two, only one will give positive result and then the other one will give negative result. Okay, to write the correct way, basically you need to write both two equation. One is negative result and another one is positive result. So let's highlight what need to be in your answer. First, you need to give the name of the chemical test, Lucas test, and then you give the reagent. This is the second thing. Okay, first thing is the name of the chemical test. Second is the reagent, and then the third one is the the third one is the observation. So at where you have to mention for the Turin, no cloudiness appear. And for the cyclohexanol, it is secondary, so the solution will turn cloudy within 5 to 10 minutes or after 5 to 10 minutes. So the fourth one is we need to give the equation. So when you give the equation, please make sure if there is reaction happen, so you're going to write down reactant and then no observable change. Okay, for the negative result. While for the positive result, you have to show the functional group of the hydroxyl group will replace by the Cl from the zinc chloride. Okay, so now proceed to question B. You also will note it first, write down the name of the test, Lucas test. Second, the reagent. Third, the observation. And fourth, the equation. So like just now, we already mentioned that the tertiary alcohol will give positive result towards the Lucas test, where we have to mention cloudiness appear immediately. While for the primary, no cloudiness appear, but the way we write in the equation, we have to write down no observable change. Okay, tutorial question number 9. Compound P is an alcohol. So if alcohol can be either primary, secondary or tertiary, you keep in mind that upon oxidation with acidified KMnO4, a ketone Q is formed. So means if ketone is formed, so means that the P is secondary alcohol, because secondary alcohol undergo oxidation produce ketone. While if tertiary alcohol will not be oxidized, while the primary alcohol either oxidized become aldehyde or carboxylic acid based on the strength of the oxidizing agent. Okay, so and then P will react with PBr3. So yes, we also can confirm that P. So we write down the reaction first. P undergo oxidation. P is second. At first we know that P. Okay, sorry. Let me start again. So when we read the question, we say that P is an alcohol. Okay, upon oxidation will produce Q, which is a ketone. So from this statement, then I know that LP is the secondary alcohol. So and then at the same time, P will react with PBr3 to produce R. So as we know, what OH will be replaced by the Br. So this R will be secondary haloalkane. And then R, which is purified and reflux in dry ether with magnesium to form Grignard reagent X. Okay, so magnesium in dry ether will produce Grignard reagent, which is the S. So and then both S and Q react will and followed by hydrolysis will produce 1, 2, 6, 1, 2, 3, 4, 5, 6, 3 hexanol, 3, 4 dimethyl hexanol. So complete with the hydrogen, CH2, CH, CH2, CH3. Okay, so basically we know that the origin of the Q, if we trace back, Q is from P, S also from P, S get from R, R also get from P. So that means the compound 3,4-dimethyl 3-hexanol basically consists of 2P. Okay, that means 2 secondary alcohol which is similar. Okay, and then from here we also notice that ketone, if react with Grignard reagent, undergo hydrolysis will produce tertiary alcohol. So yes, this is tertiary carbon. So the product 3,4-dimethyl 3-hexanol is the tertiary alcohol. So now draw the reasonable structure for P, Q, R, and S, and then write all the equation for the reaction involved. So basically, based on the name here, 3,4-dimethyl 3-hexanol total have 8 carbon. Okay, and then this 8 carbon is come from 2 compound P. So in other words to say, each compound P consists of 4 carbon. Okay, so now as we know, P is the secondary carbon, secondary alcohol, and then with 4 carbon. So we predict this will be the structure of the P, CH3, CHOH, CH2, CH3. So if this is the P, when P undergo oxidation, produce the Q, it will become CH3, C double bond O, CH2, and CH3. Okay, then the structure R, alcohol react with the PBr3 will produce CH3, CH, the OH will be replaced by the Br, and CH2, CH3. So next one is react to PQRS. So S is the Grignard reagent, at where we will get CH3, CH, MgBr, and then CH2, CH3. So these two when react, so as we learned in chapter haloalkane, I always say that I will start from the ketone compound, which here will be CH3, C double bond O will become single bond O, and then attached to CH2, CH3. So for the Grignard reagent, the bond will break between the carbon and the MgBr. Now the MgBr supposedly will next to the oxygen, but then later will follow by hydrolysis. So the MgBr will be replaced by the hydrogen, and then this one now here will bonded to the carbon, and the carbon has one bond bonded to hydrogen, one bond to CH2, CH3, ethyl, and then another bond is bonded to CH3. Okay, so sorry if you think that you can't see it, maybe I can just change the structure using the red color one so that you can see. Okay, so the bond is right over here. So this is the carbon. So we're bonded to this carbon. And then this carbon, one bond is bonded to CH3. Another bond bonded to ethyl group, CH2, CH3. And then the last bond is bonded to the hydrogen. Okay, then next we are going to know that we have 6 carbon. So at where, look at here where we can get the carbon. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So we will get 3 hexanol, and then this is the substituent, and then this one also the substituent. Let's highlight the substituent, which is the 3,4-dimethyl. 3,4-dimethyl 3-hexanol. So this is the product. So when we get this structure, so we know the structure P, Q, R, and S that we draw just now is correct answer. Okay, so now after we predict the structure of the P, Q, R, and S, and then don't forget the question also asks us to write the equation. So the first equation is from P to Q, and then we can have P to R, and then is R to S, and then is S plus Q. The last equation is S plus Q. Okay, so look at the first equation. So basically what we want to emphasize here is you need to include the reagent. So the reagent is the one which will give you the marks. So P to Q is done, and then P to R. So basically you just like the marks is already in the question. Okay, you just rewrite back on it. And then the next equation is R to S. So the haloalkane react with magnesium dry ether and then produce the Grignard reagent. Last equation is the Grignard reagent react with the ketone and then undergo hydrolysis. So we'll produce 3,4-dimethyl 3-hexanol. So we already finished this class tutorial question for the alcohol, question number 4 until question number 9. So in next video, I will discuss the objective question with you. Okay, see you in next video. Bye bye.